Alright, so this is section 6.5, which is about the properties of logarithms. So there are some properties that are derived from the exponent laws that we can apply to logarithms. The first one is the product rule. It says if you have log base b of m times n, that means you have a multiplication inside of the logarithm, you are allowed to split it up into log base b of m plus log base b of n. So multiplication splits up into addition. And that's just like your exponent rule. With your exponent rule, when you had multiplication, you added exponents. Well, same thing here. When you have multiplication inside the log, you add two logs. Quotient rule, log base b of m divided by n. When you have division, you are allowed to split it into two logs with subtraction. So log base b of m minus log base b of n. And again, this comes from exponent rules. When we had division, we subtracted exponents. Same thing here. When we have division in a logarithm, we turn it into the subtraction of two logarithms. Our third one is the power rule. This says when you have a power up here, log base b of m raised to the p power, that p power can be moved to the front. And you have p times the log base b of m. So any powers can be moved to the front. Now, these three can also all be read in reverse, meaning if you have a number in front of a log, you can actually move it back as an exponent. Or if you have the subtraction of two logs, you can combine them together into one log that just has division in it. Or if you have two logs being added, then you can combine them together into one log that has multiplication in it. So you can read them either way, from this to this or from this to this. The last one is our inverse property, which we talked about in 6.4. But just remember that if you have an exponential and a logarithm with the same base, they can cancel out, and you just end up with whatever was left. So here, exponential base a, log base a cancels out. All we have left is n. Here, log base a, exponential base a cancel out. All we have left is r. So just remember that property. All right, so let's do some examples. Example 1 here asks us to find some different expressions. So we have 2 raised to the log base 2 of pi. This is an exponential with a base 2, and that's a log with a base 2, so they will cancel each other out. And so we just get pi. Over here, log base 0.2 of 0.2 raised to the negative square root of 2 power. So this is a logarithm with a base of 0.2 and an exponential with a base of 0.2. So those will cancel out, and all we'll have left is negative square root of 2. Over here, ln of e raised to the kt. Remember that ln is a log with a base e. So this is a logarithm with a base e and an exponential with a base e. They will cancel out, and so we'll just get kt. And so all three of those just used our inverse property here to allow us to cancel out logarithms and exponentials. Our second one asks us to use the product rule to expand each logarithm expression. So we have log base 4 of 7 times 5. That's a multiplication, so we can rewrite it as an addition. So this is log base 4 of 7 plus log base 4 of 5. So we expanded it out into two logarithms. All right. B over here, we have log of 10x. So this 10 and x have a multiplication between them, so we can split them into addition. So this is log of 10 plus log of x. Now here's the thing though, we can actually simplify this a little bit more. This term right here, log of 10, remember when it just says log, that this is really log base 10 of 10? What power's on this 10? Technically it's a 1 power. So I have a logarithm with a base 10. I have an exponential with a base 10. They would cancel out. All that would be left behind is the power, which is a 1. So this is actually 1 plus log of x. And you do want to simplify things like that. You want to simplify it as much as you can. So that's our product rule. Not too bad. Example 3 asks us to use the quotient rule to expand the logarithmic expressions. So here we have log base 7 of 19 over x. That's a division, so it can be expanded to a subtraction. Log base 7 of 19 minus log base 7 of x. Can't really do anything to simplify those, so that's as much as we can do there. All right, letter B, we have ln of e to the third over 7. So we can actually take that division, split it apart into a subtraction. So this is ln of e to the third minus ln of 7. Remember that an ln is a log base e. If you need to, you can go over here to the side and you can kind of write it down. This is a log base e of e to the third. And since you have a log with a base e and an exponential with a base e, they can cancel out. So all that's left is the 3 minus the ln of 7. So that's how it would expand. Okay. Example 4 asks us to use the power rule to expand each logarithmic expression. So we have log base 5 of 7 to the 4th power. So we can take the power, bring it to the front, and be 4 log base 5 of 7. Letter B, we got ln of square root of x. So a square root is a type of power. It is a 1/2 power. So this is really ln of x to the 1/2 power. So that 1/2 power can be brought to the front. So this is 1/2 ln of x. All right. Letter B, we have log of 4x raised to the 5th power. Now, this does have a 5th power, so we can bring that power to the front. So we have 5 log of 4x. But we can actually do one more thing here. That 4 and that x are being multiplied, and when we have multiplication inside of a log, we can change it into addition. And when we do that, that 5 will stick with the log, so you're going to end up with 5 log 4 plus 5 log x. And so that used a little bit more than just the power rule. We use the power rule to move the power to the front, but then we use the product rule to split the product up into an addition. And that's what we're going to be looking at next, is using all of these properties to fully expand something. And that's what the little paragraph here says. We can basically use the product rule, the quotient rule, the power rule, and use it to fully expand a logarithmic expression as much as possible. Generally, the best strategy, what I usually follow, is to try and break apart divisions first into a subtraction, then try to break multiplications up into an addition, and then at the very end use the power rule to bring powers to the front. That's usually the order in which I handle things. You're free to do it in a different order, because technically, in terms of order of operations, all of these happen at the exponent level. So the order that you do them in does not necessarily matter, but sometimes it's easier to do it my way. So here I gave you some steps for expanding logarithmic expressions. Step 1, use the quotient rule to change division into a difference, into a subtraction. Step 2, use the product rule to change change a product into an addition, into a sum. And then lastly, use the power rule to take your powers and bring them to the front. Okay. So let's look at that here in example 5. Example 5 asks us to use the logarithmic properties to expand each expression as much as possible. So I have log base b of x squared times the square root of y. So first thing is quotient rule. Do I have any division? No. So step 1 is done. Step 2 is product rule. Do I have any products? Yeah, these things are being multiplied, so I need to split them apart with addition. So I'll have log base b of x squared plus log base b of square root of y. And then lastly, use power rule to bring powers to the front. So here, this 2 is a power. It can go to the front. 2 log base b of x plus. That square root is also technically a power. Remember that, again, a square root is a 1/2 power, so this is really y to the 1/2. So that 1/2 power can be moved to the front. And so we'll have 1/2 log base b of y. And that's as much as we can do using our properties of logarithms. Alright, letter B is a little more complicated. We have log base 6 of the cube root of x over 36 y to the 4th. So first step is use a quotient rule. Do we have anything being divided? We actually have 2 things being divided. We have a 36 getting divided and a y to the 4th getting divided. So we're going to need to change this into a subtraction. So we'll have log base 6 of the cube root of x minus log base 6 of 36 minus log base 6 of y to the 4th. I did separate these because since they're both being divided, they're both going to be a subtraction. Alright, the next thing would be look for any products. There are no products left. When we separated the division, that broke apart that product, and that's okay. So the next thing is powers, but before we get to that, I want to do something really quick. I see this is a log base 6, and I see here we have a 36. 36 is a power of 6, so I'm going to rewrite it really quick. So I have log base 6 cube root of x minus log base 6 of 6 squared minus log base 6 of y to the 4th. Alright. And then we're going to do 2 things. We're going to bring our powers to our front, and then we're also going to simplify this middle logarithm. Now here, when you have this cube root right here, the cube root is a 1/3 power, so this is x to the 1/3. So you're going to take that and bring it to the front. 1/3 log base 6 of x minus, here we can actually use our inverse property. We have a logarithm with a base 6, exponential with a base 6. They can cancel. All that's left over is the 2 from the exponent. And minus, on this one we can bring the power to the front, so we have 4 log base 6 of y. So there we go, there it is, fully expanded. Okay, so that's expansion. You just use your properties to break them apart as much as you can. All right. We can also go in the reverse order to condense logarithms, meaning we can take 2 logarithms that have the same base and we can combine them together into 1 logarithm. And the process just kind of works backwards. So your first step, you're going to use your power rule in reverse to take numbers in the front and bring them back up as powers. Step 2, you're going to use your product rule in reverse to take an addition of logarithms and combine them into 1 logarithm that has multiplication. And then lastly, you'll use your quotient rule in reverse to change any subtraction back into a division. Right. So example 6 here asks us to write these expressions as a single logarithm. So for A, we have log base 4 of 2 plus log base 4 of 32. This is an addition, so we can use our product rule to combine it back into a multiplication, 2 times 32. Now, what is 2 times 32? 2 times 32 is 64. So we have log base 4 of 64. And normally I'd say we're done, but it just so happens that 64 is a power of 4. So I could actually rewrite this. 64 is 4 to the 3rd power, I believe. Let's double check in the calculator. 4 to the 3rd. Yeah, that's 64. So we actually can rewrite it like this. And now we have a logarithm with a base 4, an exponential with a base 4. Those can cancel out, and all we're left with is 3. So when we combine these 2 logarithms together, we just wind up with the number 3, which is really nice. Alright. Here at letter B, we have log of 4x minus 3 minus log of x. All we have is a subtraction. A subtraction can be rewritten as a division. So this is log, and inside the log we're going to have 4x minus 3 divided by x. And that's all we can really do. Now, one thing I want to point out, when you rewrite it into a division, you do not write the word log twice. When you're condensing, the number of times you write the word log should go down. So in the problem, there are 2 logs, and I've condensed it now, it's just 1 log. You shouldn't still have 2 logs. You shouldn't have log log, okay? It should condense down to just 1. Alright, so those are pretty straightforward. Let's look at some that are a little more complicated, though. So our directions in example 7 asks us to write each of these as a single logarithm. We have 1/2 log x plus 4 log x minus 1. Well, when we condense, the first thing we usually do is take a number in front and rewrite it as an exponent. So this is really log of x to the 1/2 plus log of x minus 1 to the 4th power. Now, a 1/2 power, remember, is a square root, so this is really log of square root of x plus log of x minus 1 to the 4th. And then the last thing we can do is there's an addition here, so we can combine these 2 logarithms with multiplication. And so we get log of square root of x times x minus 1 to the 4th. And so that's condensed down as much as it can be. Alright. Letter B, we have 3 ln of x plus 7 minus ln of x. Again, there's a number in front here, a 3, so I can bring it up as an exponent. So this is ln of x plus 7 to the 3rd power minus ln of x. And then I have a subtraction between these 2 logs, so I can condense it into a division. So this becomes an ln of x plus 7 to the 3rd power over x. And so there's my condensed form. Okay. Now in each of these so far we've only looked at 2 logs, but we can have more than 2, which is what we're going to look at here in letter C. So here we have 4 log base b of x minus 2 log base b of 6 minus 1/2 log base b of y. First thing we're going to do is we are going to take numbers and put them back as exponents. So we'll have log base b of x to the 4th minus log base b of 6 squared minus log base b of y to the 1/2 power. And then I'm going to do a little bit of rewriting. This is log base b of x to the 4th minus log base b of 36, because that's what 6 squared is, minus log base b of square root of y, because square root of y is what y to the 1/2 power is. Alright. Now you might notice that this second log and this third log are both being subtracted. That means they are both being divided. So when we rewrite this into one logarithm, we'll have log base b. On top we're going to have x to the 4th. And then on bottom we're going to have 36 and the square root of y. Because both of those were subtractions, so they're both being divided. They're both on the bottom. So there we go. That's as condensed as we can get it. Okay. So condensing is really just expanding backwards, and it's not too bad. All right. The last thing we're going to do is we're going to talk about the change of base formula. Yep, that's the last thing, right? Yeah. Change of base formula is a formula that allows you to take a logarithm that is in one base and change it into another base, which is useful for putting logarithms into calculators, because we can take a logarithm and rewrite it into either base 10, or we can rewrite it into base e, and then we can actually use our calculator. So the way our formula goes is log base b of m is equal to log of m over log of b, or it's equal to ln of m over ln of b. It doesn't matter whether you use common logs or natural logs. What matters is, one, that you use the same thing on top and bottom, and two, that the m goes on top and the b, the base number, always goes on bottom. Now, to prove that it doesn't matter which one we use, in example 8 and 9, we're going to evaluate the same logarithm, but in one of them we're going to use common logs to help us evaluate, and in the other one we're going to use natural logs, just to prove that it doesn't really matter which one we use. So in example 8, it asks us to use common logs to evaluate log base 5 of 140. So I can say log base 5 of 140 equals log of my number inside here, 140, over log of my base number, 5. And then I go to my calculator. So I'm going to do log of 140. I'm going to close that log, divided by log of 5, close that log, hit enter, and I get 3.070. Okay, so that's what I get when I evaluate it with common logs. Okay. Example 9, we're just going to do the same thing, but this time we're going to evaluate it with natural logs. So we're going to say log base 5 of 140 equals, we'll do ln of the number inside, so 140. Oops, sorry, my parentheses are pretty bad. Over ln of the base number, which is 5. And then we go to our calculator. ln of 140 divided by ln of 5. And hey, look, I get the same number. It doesn't really matter which one I use. They're exactly the same. So I still get 3.070. And so the point I'm trying to make here is, when we talk about change of base, we can put logarithms in the calculator. I don't have a preference which one you do. Just make sure you do the same one on top and on bottom, and make sure that the base number always goes in the log on the bottom. All right, so that is it for 6.5 notes. As always, if you have any questions, feel free to send me an email.